Hello, everybody. So, we're moving into chapter 15, and we're going to talk about, um, atmospheric pollution, the effect of, what the good ozone is versus the bad ozone and all that stuff. But first, we get to go back to chapter 4 and look at how does the earth get heated? What are the layers of the atmosphere? We really didn't touch on it then because I like to touch on it now because this is when it makes more sense to me. Okay. So, first things first, let's look at what the different layers of the atmosphere are. The one that we live in is called the troposphere. That is where all of our weather occurs, and it's from the ground up to about 10 miles. Depending on that's about average. Then the next one up is called the stratosphere. You may have heard of the hotel from Vegas. This is where it gets its name. It goes above the troposphere, and the stratosphere and the troposphere are going to be the more important ones as we move ahead. So here, what we see in this picture is the troposphere. Like down here is Earth's surface. And here is the troposphere. So it doesn't go all that high up. Then that's where we have what we call our peak ozone layer and then our stratosphere. So the stratosphere is just above it. Then we have mesosphere, meaning middle. Thermosphere. What do you think it's called? Thermosphere, huh? Here, let's look at the temperature. The temperature goes it really increases during that thermosphere. And then that's the exosphere. The exosphere is basically space. Yeah, basically. So you can see that the temperature in the troposphere actually decreases as we get higher. And then we have the ozone layer. And then above the ozone layer, it gets warmer. And then during the mesosphere, it cools off a little bit. And then here in the thermosphere, it gets cooler, and then it's like, wha-bam, it gets hot. So here, this is also important to look over here because it talks about how the density decreases with altitude, and that's because there's less molecules of gases in the air, fewer of them. So there is less oxygen, less carbon dioxide, et cetera, et cetera. Temperature, I already kind of went over that. And then what's also important to note is because the reason why the temperature goes up in the stratosphere is because that's where the sun's UVB and UVC rays really warm up that part of the atmosphere. And thankfully, the ozone layer blocks a lot of that from reaching us down here in our troposphere. Yeah. Okay, so let's talk a little bit about what's going on in the atmosphere. How is it that the sun warms the earth? So one thing we know, the earth is tilted. It is tilted. It wobbles a little bit. It varies very slightly. But the main thing is as the sun reaches the earth, the angle at which the sun's rays hit the earth really determines on how direct that sunlight is or indirect. So when it's more direct, guess what? It's summer. When it's less direct, it's winter. So right now we are moving from more of an indirect to more direct as we're warming back up seasonally. Some areas of Earth reflect more solar energy than others. This is what we talk about, that albedo. And that albedo is really important in polar regions. And remember when it snowed, it was so bright white because that was a really high albedo. It almost like hurts your eyes. And that sun comes down and reflects back off the white. So in those areas, you actually get more reflection away from the atmosphere versus, hold on, I have to pause something. Hold on. My child is being super annoying. Let's see how that does. All right. Anyways, back to presenting. So, and it also kind of varies where you are locationally. So if you are around the equator, then obviously you are going to get more direct sunlight. Yeah. All right. So look at this cool picture. It kind of puts everything we just said in perspective for you. If you are a visual learner, So here you can see that the sunlight, obviously, as it strikes Earth, the closer you are to the poles, the less direct sunlight you're going to get. So that those high latitudes, you are not getting as much direct solar energy. And then also at the equator, you're technically one closer to the sun, but also two more perpendicular to the sun. So you get more direct heat there in sun. So this is in a picture of kind of how albedo affects how energy, how the sun's energy reaches Earth and how Earth basically deals with it in a way. So water, depending on the color of the water and the clarity and the sun's angle, it can go anywhere from 10 to 60% of that light is reflected off. Um, ice, snow, those types of things, white surfaces, they reflect a lot, in almost on average about 90%. Darker substances, asphalt, concrete, forests, because they are darker in color, absorb more light. Well, and also think, why else do you think forests absorb more light? Photosynthesis. That's right, right? They also absorb a lot more of that energy for that reason as well. So this also takes a toll whenever we're talking about climate and climate change, and how areas like the glaciers are melting at such an exorbitant rate, and how we have to slow that down. Well, it's warming and warming and warming, melting, melting, melting that reflective surface, turning more into darker surface. So therefore heats up more. That is, it's quite the positive feedback loop there. So Earth's tilt does help us with our seasonal changes. It's on average about 23.5 degrees. And so when the northern hemisphere is where we live, it's tilted away from the sun. Then that's more when our winter time, and that's when the southern hemisphere is tilted towards the sun. So it kind of, back and forth. All right, so this picture here shows you how we have our solstices and our equinoxes. So the solstices are the shortest and longest days of the year. The longest day of the year is the June solstice, which is where we have more daylight than any other day of the year. And then the December solstice is where we have the least amount of daylight between sunrise and sunset. Excuse me. Then the March and September equinoxes, that's where we have halvesies. We go halvesies, 12 and 12 hours. All right. So that's all from chapter 4 that you need for this. We did air currents back in the day. You might want to kind of go back over this a little bit as we move back, as we're going to plunge into chapter 15. But I'm not going to cover it again. All right. But if you feel the need, then please review. Okay.